Deloitte Innovation Lab here at Communitech. So what we actually do in the lab is we build prototypes for minimally viable products and proof of concept. So the demonstration you're going to see today is one of the prototypes that we build. So we don't as a team, we don't focus on particular technology. We're not blockchain experts. So personally, I think what you're going to see is really cool in terms of what the team developed in the course of about 5 months from zero to what you see today. So we've learned everything we needed to learn about blockchain. We had students, we had our team headed by Ganita. So Ganita Sinai is going to be presenting the demo today. She's one of our senior leads in the lab, and she heads up our architecture and software development, as well as she was the product management lead on this project. So I'm going to hand it over to Ganita to walk through the demonstration. You're going to see a snippet of the demonstration, so if it teases your interest, we can set up another time to walk through the full demonstration, because it's quite lengthy.
Hi, I'm Punita. So first a bit about the use case and the prototype we started to build on the blockchain. So it is a trade finance, international trade use case. Liliana mentioned about it a bit. So I'm going to show you the video, which is created by our business team in Toronto. And this sets a good context of what the trade finance is and why are we doing blockchain on trade finance. I'm not going to show you the whole of the video because when it goes to the part of selling you anything, I'm going to stop. But before that, but it sets a good context of what we are trying to do here.
Well, we're clear. You guys have with us today.
Okay, so maybe I'll just talk about it. So the use case is mostly when the goods on international trade are being sent, it's between the buyer, the seller, the financier. So
pain points exist, most notably, onerous manual review of financial agreements. Trade financing, where financial institutions provide credit facilities in order to guarantee exchange of goods, is a centuries-old industry that hasn't seen much change with the growth of global trade flows. In 2015 alone, the trade finance market was measured at more than $10 trillion US. Existing models are complex, inefficient, and costly, requiring multiple parties and significant levels of manual processing. Banks have high operating costs and risks of fraud losses, while buyer-sellers face a plethora of paperwork and delays, resulting in a poor customer experience. Multiple pain points exist, most notably, onerous manual review of financial agreements, dependence on intermediary correspondent banks for payment, shipment delays due to numerous communication points and paperwork, high probability for fraud with disparate systems. Deloitte has reimagined how trade finance can operate, leveraging a blockchain-based infrastructure to drive efficiencies, reduce cost base, and open up new revenue opportunities, like newer models of credit and funding guarantees backing the trade. Let's imagine that a buyer in Vancouver, Canada wants to buy 100 automotive tires from a seller in Hong Kong, China. We represent the obligation of the buyer to pay the seller for the goods, tires in this example, upon receipt of the goods as a blockchain-powered smart contract that underpins the flow. As a first step, the purchase order is created by the buyer and a corresponding smart contract is created on the blockchain to codify the obligation. Having the complete details of the order on the blockchain allows financiers, institutions like today's banks who provides credit facility to the buyer or a financial guarantee to the seller to review the terms of the purchase order in real time. Once the financier provides guarantee of payment, which is captured on the blockchain, the seller proceeds to prepare for shipment of the goods. Using the provided assurance, the seller would ship the goods and link the invoice to the transaction on the blockchain. Similarly, in the supply chain, the shipping company would be able to provide shipment tracking details, including bill of lading, and the import-export custom agents in respective countries would be able to provide clearance details that are written to the blockchain. Finally, when goods are received by the buyer and inspected, blockchain will enable capture of acknowledgement and receipt. The payment to the seller will then be triggered based on rules and conditions coded in the smart contract. If buyer is unable to make a payment upon receiving the goods, payment default rules will automatically ensure payment to the seller based on assurance provided by the financier. In this case, the funds would be settled from financier to the seller.
I'm going to stop here now. This gives a good idea what the use case is. There is buyer, there is a seller, the financier who does de-risk the whole transaction for the seller, and then there is the shipper who actually moves the goods. So I'm going to turn on these TV screens. There are so many screens that I have here to do the blockchain demo presentation, and I think that's to what Julia had. Figuring out the UX, so that was our bigger motives behind this project. First, how do we figure that UX so that we can connect people with what's happening in the blockchain and still not like completely be like, oh, okay, what is this? And then how we can figure those technologies out too. So while we were figuring the technologies, we were also working on the use case. So this is what we have been trying to do here. We have been trying to find some, so I'm just going to focus on few technology aspects of it because I cannot cover all of it right now. But then I want to give it at the end, want to see if I'm able to attach you with what the blockchain is. Like how, so we have given you an idea of the use case, but now I'm going to more focus on the blockchain aspect of it. And that's why I have these multiple screens here. Actually, I need to use the projector screen as well, so I'm going to take this away and put another screen there. Okay, we have it here. So what do you see here? So this screen, which is on the projector, is the user journey. It explains to you the various steps which are involved in a trade finance use case. It is a long use case, so it involves multiple parties. But then, what we talked about in the video, it's rules coded in a smart contract. So all these rules, they're coded into the smart contract, and as we proceed with every step, those rules are being triggered at different points of time. I am a tech geek. I might just run faster on all the technology stuff, so please stop me because this can totally happen. Stop me and I'll explain how much as I know, and I can connect with you later on as well and explain different things that we did here. This one that you see here, so that the first one, the user journey, as I explained, it also shows the state of the smart contract. So as soon as I do something, it will show the smart contract triggering, starting to working on it, and then when the state changes, it will show you the update there. This thing is the ledger. So we keep saying blockchain is the permanent ledger. So that's what we have tried to show here, the permanent ledger. So when the state of the network is being updated, what do I see in the ledger? That's what this shows you. So I am triggering transactions on my application, and then I'm seeing those transactions appearing from the blockchain ledger. So this is kind of an insight of giving what's in that ledger, what we always talk about. This here is the DApp. DApp, the web applications which we are so used to. We have been creating web applications for the last 5 to 10 years now. So we need that kind of an experience to be able to attach to this backend technology. So that's what we have tried to do here. So when I'm moving around in the DApp, switching between multiple personas, you will see things happening, the state changing on the smart contract, and then the ledger, to get the transactions coming on the ledger. So I think I need to grab that keyboard to do the stuff. have 4 personas in the user journey. You will see here, I think I can make it easier for you guys to see. Okay. So these are the 4 personas in our user journey, and I'm going to be switching among them. Their view, their DApp views, I'm going to switch among them, and I'm going to show you what each one sees at each point of time. I am in now as the bill the buyer. So in traditional sense of trade finance, there would be a letter of credit. So a buyer will go to a bank and then get those approvals, and the bank will create the letter of credit for them. Now, for us in this scenario, the buyer himself is creating an agreement. So it's not letter of credit, but it's just an agreement with adding required parties into that agreement. I have already created an agreement here, so I'm just going to open that for you and show you how that looks. So this agreement, which has a unique agreement number, which is identified throughout with that number, and then it has all these fields. So similar way how it is, like you need all that information to go through multiple parties, every party need to sign that, and then you can start the transaction. So it has all the fields in there. It has buyer information, it has seller's information, it has financier's information. There are some terms of sale. So we have just used terms of sale for an example purpose. It could be more than that. There could be like 50 terms of sale to make the transaction valid. And then there is this purchase order, which tells these are the number of goods I'm buying. Very simple looking purchase order. It could also potentially later on, be an ERP system. It could be anything later on, but we have just tried to show it in a proof of concept perspective. So what stays in the blockchain and what stays outside of blockchain? Not all of these fields stay in the blockchain. All these fields are in a decentralized storage system, which is called as IPFS. So all these values, because we figured, is it really beneficial if I store all these big fields in the blockchain itself? Maybe I'm making my transactions heavier using that. So we are storing all these fields in an IPFS system and saving their hashes into a blockchain network. Also, what we are saving in our blockchain network is the privacy information. So all the rules in our smart contract, that we are putting it there. So that's in the blockchain. Who can see what at different points of time, that's in the blockchain. And also what we are storing in our blockchain is the digital signatures. Because this is not valid to a seller, this contract, until financier signs it. So that information we are storing in the blockchain. So that later on I can go any point of time and I can check that. So as I mentioned, the privacy aspect of it, right now the smart contract is being created by the buyer, it's sitting with him, and it should go to a financier now. And so to go to the financier, so seller doesn't need it right now. Seller only cares about it only when financier signs it. So if I log in into the seller's profile, you don't see anything, because it shouldn't come to the seller until the financier has put their signature on it. So I'll go into test financier. I see there is this agreement sitting for financier, and it has a red circle around it, a pending action. So I'm going to select that. As a financier, I'm going to go through all the details. I have the same purchase order attached with me here as well. So all this sharing information is in the smart contract, the rule written in the smart contract. I say, okay, it all looks good. I'm going to accept it. I'm going to add my digital signature to it. So I accept it. As soon as I do that, so the state of smart contract changed. It started mining. And then this happened really fast right now, but it was mining here as well. So the blockchain network was also, as soon as I sent a message, blockchain network started working as well. And then when it was done, it just showed you this agreement has been accepted. So this information is coming from the ledger itself. So if I open this, you see all the information coming from the blockchain ledger. There is this transaction hash, a really long, big 32-bit hash. There's this block hash, block number, ID, all that. So when it's in my ledger, this is the way I can see it is there and it's always there. If you want to see, and if the group is interested, we have another another option here to view the pseudocode. So if anybody is interested to see how a smart contract really looks like in a coded version, this is a pseudocode for that. So if I switch this, it's a very pseudocode way of what actually happened to make this happen later on, to get the transaction working. So that is one. I can go on and show you in the user story. I can switch between, go to the seller's profile, accept from the seller's profile. And the same thing will happen. It will trigger a transaction. It will change the state of the smart contract, and then it will look into the state of the network and show you from the ledger. So that's how. But another cool thing that we have, another concept in the use case implementation, is the concept of smart oracles. Has anyone or many people would have heard of what smart oracles are? So I'm using a mobile application, and this could be for a shipper. A shipper, in current time too, UPS, if you buy something from them, they give you a tracking number. And then that tracking number is scanned by the mailman, and you can always go and check online where your goods are. So in the same way, but this thing is not in the network. This is a trusted third-party app which is going to send you data into the blockchain network. The blockchain network trusts it, so it's going to accept it, and it's going to create a transaction into the ledger. So later on, when I go back, I can always go and check where my goods were throughout the time. In the international trade, that is really important because that's the ports, that's how the bill of lading is going to happen, that's how terms of goods happen, all those things. So I'm going to show just one. So it's not very visible. I couldn't cast it, but this is a simple scanner app, and I have these bunch of barcodes which just scans where the goods are. So I'm going to scan it for that purchase order, a barcode. I have the scanned information, and I'm just going to submit it. It says it's been sent. Okay, see there, and then location receipt. The internet is really fast here. Like, in our lab, it is so slow. We're just looking at that bar going on, and we're just like, we don't believe our blockchain network. And we keep complaining to these Nuco guys because we're using their platform, and I think it's just our internet. It's really fast. So yes, we have built this application on a private network since I just thought about it, and we built it over Nuco. So if you have any private public network conversations, we have a better person in the audience who can answer them better than me, because I've tried to answer those questions, but of course, he'll be a better person to go and ask them. So another aspect that I wanted to touch on, since I send the location information, if I go here, and I'm probably confused with what keyboards I was using. Nom told me to name them, but I didn't do that. So if you see the location information, you just see, so this is, dashboard is the public view. Why do we have this dashboard? Because we are in the early age of blockchain. It is just like how internet we used to create those diagrams, the gateway, and then the call goes there, and the message gets transmitted. That's how because we want to show people what ledger looks like. When we say the permanent record, what does that mean? So that's why we have these dashboards. But in the real case scenario, there would be more private view of that information, more like notifications for each persona, every persona. So like shipper, it's just a transportation company. In this story, they shouldn't be able to see anything that's going on because that's the private data. So in our story as well, we have implemented that. We have implemented that buyer, seller, and financier, they see everything. but then shipper doesn't. So as you see here, I send location, but you don't see any location information. Because even if somebody can see your transaction, they cannot see the contents of the transaction. They would know something happened, but they would not know what was in it. So here you don't see what is in it because this is a public view of the whole information. So if I go here, I'm going to quickly pull up notifications. So since I'm the seller, I should be able to see all the notifications. I'm going to select that. This is coming from blockchain, so it takes a second. But I know it's not super visible, but if you see here the location receipt, and you will see location change to Port of Vancouver with that, email, the code and stuff. So that is the information which was inside the transaction. So all those privacy rules, all they exist in the smart contract. It is how you implement them and how do you show them. So those are the various things that we have tried to bring up in our use case and we have tried to implement. So we have tried to do the technology aspect of it, figure out what all these technologies are. As an innovation lab, we're very interested in that. Like everybody is talking about it. Can you actually do them? So we got a use case, a live use case from the business team, and we started working on it. And then once we were figuring out the technology, we were like, how now we show this to people? Like if I just show them the big screens with consoles and stuff like that, I'm going to scare everybody. And nobody is going to come and give me another use case, how I work on this. So that's how we have tried to, and we are updating our UX all the time. So we have done, I've done so many demos. The business team has done so many demos, and then we just get that feedback and then we include it in our UX. So if you are interested in any more information regarding this, if you have any questions, let me know.
Any questions at all?
You were to find this, right?
Deloitte Lab on the main floor.
A specific question about agreed price. So the price is locked into the contract. It's initially agreed upon, and then it gets sent via a blockchain through your own crypto or through Bitcoin. Like I never seen it.
So we are not doing the payment piece in this at all. So we are sending this much you owe, but then we are left it there.
So the
After
payment's not
that.
getting done through crypto.
Yeah, so it could be integrated through any way. It could be a direct transfer, how it happens nowadays, like still now. Or it could be a Bitcoin, it could be anything. So it is left open. So this use case was, the idea was to do an end-to-end generic implementation, go show it to people and get these conversations. And then think of what we need to add more in this, if we are doing trade finance in the existing use case.
Is there the possibility for, and you can't discuss this, I understand, but is there the possibility for your client or the user to customize for certain alerts or conditions that you brought up? I'm thinking about things like trade compliance. If it's an order under a purchase order, it might not be reviewed, even though that's the process. So if you put in the country to ship to, it's on a trade block list, is that something? Because that could be a very good, useful enterprise solution. So if someone types in Iran, instead of allowing it to go through, it says, actually, you're not allowed to ship to Iran. Is that level of customization available to your platform? Or could it?
I'm not sure because it is the set of rules that we put in the smart contract. But I think once we have sent it, it's there, right? It's gone. But of course we can. So I cannot change. I can add stuff to the existing agreement. I can keep changing that. But what's already on it, it's in it. So if I have to, in this case, I think if something like that, I have to do like change something, I might have to create a new contract. I might have to build the existing. Somebody has to decline it at some point of time. So either financier will decline it or the seller will decline it. But once it's declined, then you're like, again, you're just creating it.
I just want to tie back to Julie's original comment about this being contract law. So really, the pseudocode is a manifestation of what you actually need. It's the thing that unfortunately called hackers abstract and more sophisticated, right? So all of that's possible, but then it gets down to how do we collaborate to pull it all together. So again, stitching all this together, it's a really hard problem to solve, right? But it's all possible. That's what we want to show. It's just a bit of code running on a secure network, decentralized code, running on a secure network where we know we can trust it. So what's possible? Yes, absolutely.